So,
Awesome. So just to rehash, right? Kuzu has the ability to import data. Um, and there's several topics that I definitely want to talk about, and then we can discuss how we want to design it. Um, but I do think, I mean, Kuzu recommends it, right? But I think for initial indexing, initial load, it makes sense to leverage the import data, right? And essentially, when I made the first, the Rust conversion of the knowledge graph POC, I have that under, where is it? Knowledge graph old somewhere. Where is it? Um, Here it is. Knowledge graph old. Um, what I'm doing for the relationships, defining the relationships, is defining them essentially beforehand. So, like when I'm writing to the CSV, it's pretty simple. It's basically just saying like, if you look at the file result as an example, um, should hopefully read like English. Where is it? There it is. Okay. So this to write file to CSV. Um, let's actually go back. If you use bulk info, import file info. Here it is. This is where I wanted. Okay, so um, if it's using the bulk import, what I'm doing here. So we know how like in the original knowledge graph POC, just for files and directories, right? Defining the relationships is like you define the node for the directory, then
yeah.
I think we write a cipher query to define the relationship, right? And then do another cipher mutation to define the next relationship. This is essentially what I'm doing here, but I'm mimicking it by just writing the data to CSV. So
Yeah.
like if a directory, if you want to have a file relationship with the entire tree, all you have to do is just define two columns, right? And say from to, and
Mhm.
then write the parent directory to the child directory, and then another row with the et cetera, right? And then Kuzu can import that, right? Um, so I think that's how we can greatly speed this up is during the initial indexing, organize the data um, with according to I don't know why my freaking computer screen times out every 2 seconds. Sorry. Um, but essentially, what I think we can do is during the initial indexing, um, organize the data, whatever format we choose, and write it to a tabular format. We could even potentially use SQLite. Kuzu has a SQLite extension. Um, the only downside with the SQLite extension is you have to, I think, like literally install the binary that Kuzu expects you to load. So we'd have to like ship that with the binary that we build with the indexer. It might just make it too complicated. So that's what makes me what I was talking about with Parquet. I think we should figure out what's the best key value store. I don't know, my freaking screen just timed out again. My computer screen just times out every 5 seconds. It's so annoying. Um, but but yeah, so that's the first one of the things that I wanted to confirm is like when we create these relationships, how can we represent the data up front rather than doing a cipher query for every single at least the initial indexing, right? When we do incremental updates, I think at least on the client, then it makes sense to just do a basic write for a cipher mutate, or I think a basic cipher mutation, right?
Mhm.
Um, does that make sense so far? Or
Yeah, yeah, I agree that doing imports from CSV for initial import or initial indexing makes sense. The tricky part will be how there will be additional logic how to actually emulate this, making sure that you don't create, for example, duplicate records or
Yeah.
duplicate relationships because, for example, yeah, there can be multiple functions with same name defined in
Yes.
one class or stuff like this. Uh, Cipher query takes care of this to for you.
Yep.
But it's solvable, yeah.
And
Uh,
in Kuzu has the ability, so you can choose to skip errors while it imports, or you can have it fail. And if you have if you have a duplicate primary key, for instance, it'll fail. Like it won't let you continue importing. So we could either collect the errors and see if there's any duplicate primary keys, but yeah, I'm not sure
well,
about relationships. Um, but
yeah, I was thinking that we would have to make sure to generate the set of records which are valid. Uh,
yeah.
but it we attempted to do this in the POC Python POC
Mhm.
Python parser, so similar approach might be used here. So yeah, I I think that this import approach makes sense.
Yeah, so that's what I'm thinking for initial indexing. Then incremental stuff is, I think, is best done with mutations. And then I don't know why my screen just keeps timing out. It's like I'm just gonna.
So these mutations, I think this is tricky because doing mutation assumes that the indexer talks directly to the Kuzu database, but on server side it implies that indexer would talk directly to the database,
Well,
but
I'm
it would
thinking.
be simpler to just have same interface both for initial indexing and for incremental indexing, like in both cases to be able to pass some import data and the interface on graph node will take care of this. It's This is something if it would be really needed. I mean, if we go the way with Zookt reuse of Zookt index reuse, then the indexing will happen on the same node where graph database will run or will be served. So theoretically, indexer might be able to talk directly to the Kuzu database. Uh, but
No, it might make sense to just keep with only the indexing approach on the server side. Import approach, sorry. Um, I was at least saying for the client, when you're making a lot of changes, it might make more sense to just run the Cypher queries directly on the
mhm.
client um, for incremental updates. But we could, I have to see how we would delete data. Like let's say a user deletes a file, right? I don't know if we can del execute deletions from import. I have to see. Um, but
So it will be, yeah, I think it will require a bit more investigation how these incremental updates will work on this Kuzu side because uh, I imagine that when we do the incremental update, we just pass to the parser changed files, yeah. So only,
yeah,
for example, one or two files. And this parser will parse only these two files, yeah. So it will not have the complete information about what what are the real nodes outside of these files which it can refer, yeah. For example, if if in the changed file you call some class which is not part of this file but is already part of the code base somewhere else, the node for this reference class exists in database, but you don't have it in your import file or the file being
Mhm.
changed. Yeah. So, uh, so it will be tricky actually to figure this out. How?
Yeah, the on the client side, I think it, at least what I was thinking is we can, I think this the client side can probably get away with mutations. I just don't know how we would do it on the server side. Um, but maybe it makes sense to just for every change just generate a new database. The only downside with that is like if the monolith, say the monolith gets what, how many updates a day? How many merges a day? I don't know, maybe 100 merges a day? I don't know. Vitaly, you probably know. Um,
A
but
lot, yeah. So it's a huge project, and
yeah.
yeah, maybe we could do like once a day, maybe full rescan to sync everything back up. But
Hmm.
it also depends on how fast will be like scan go.
Yeah,
Yeah, so I want to
exactly.
show you guys that. So let me show you. I'm just going to share on my computer screen because my monitor keeps timing out. It's kind of annoying. So can you guys see?
Yes.
Okay, awesome. So let me just move this out of the way. Um, so the old one indexed pretty fast, right? But I wanted to see what it's going to look like for the knowledge graph. Just not much investment in the performance, right? I didn't spend too much time like actually trying to make it really fast. But uh, it's roughly what I'm thinking. So and it'll look different, of course, from server side to client side with some of the core logic. But let me show you. So first, the GitLab code parser. So I made like a Ruby, it's really basic Ruby. I tried to do some more advanced stuff, but I think there's some performance issues with the tracing. But TLDR is I have these three rules here, which essentially mimic what I think you guys are capturing in the original POC. So this is just all the calls, and then these are all the definitions, um, like basic, definitions in Ruby. I'm not
Mhm.
too much of an expert. What I'm also doing is trying to generate a fully qualified name. And this might be useful later on. We can talk about this later, but for actually matching up semantically beforehand, before we do the import, matching potential references uh, against definitions to increase the accuracy. I mean, it's not necessarily needed because I think the initial approach we should do is the same that you guys have, which is where we, define the relationships and then one reference just can be linked to many definitions. Um,
Mhm.
Either way, though, we're probably going to need, like I was saying, intermediary key value store probably in memory. I don't think it's going to be too much data. I think maybe even the indexer, depending how much memory it needs. Sorry, not in memory, on disk. But I don't think it's going to need like too much space or storage to do writes because it's pretty minimal data. But anyways, so the parser here, it's using AST grep, which uses tree sitter under the hood. Um, and so we're calling parse code. So this parses it with tree sitter and then creates the AST and the AST object. AST grep object. And then this load rules from YAML essentially just basically combines all these rules. And then this I copied literally directly from the AST grep CLI. And this run rules essentially takes the AST grep rules from the rule strings and creates a combination and then scans them. And then we can iterate over the matched info. So this is the rule ID, right? So each one of these rules has an ID. And then you can actually just access the data. So we may even want to, in the one parser design, right, just expose a method like this that can be directly consumed by the knowledge graph if we want to like walk over this data in any type of particular way. Um, but it's very similar to tree sitter in the sense that you can actually access the tree sitter node. So you could do something like, um, is this a match? Yeah. So you can do like get node, and this will actually get the real tree sitter node. So you can just iterate over tree sitter stuff as well. Um, and so if we go back to the library, um, yeah, so then I have like get definitions um, here and also references here. Um, I commented these out because I think the tracing that I did that I hacked together is not too performant right now because of how many traversals it does. Um, but if we go to the knowledge graph here, what I've got going is essentially what it does is uses this. Have you guys heard, you guys have used, I'm assuming RG, right? RipGrep. It's like a CLI tool if you're searching. I think NeoVim actually uses it, or Vim uses it under the hood if you do a fuzzy search. Um,
Mhm.
but ignore package is one of the dependencies ripgrep actually relies on. It's literally part of the ripgrep code base. And it's the most popular package for iterating over file trees. And what's nice about it is you can walk the file tree and directory in parallel. This is probably not going to apply to the server side, which is why it's good that we're talking about this because what we'll probably want to do is create an abstract indexer, which I'll show you kind of what I mean by that in a little bit. But maybe like an abstract indexer, which does the main logic, and then, it wants certain files or can accept certain files, and then we'll have like a crate for the client and then a crate for the server bindings, right? It'll accept the files. Um, and then going down here, so it's relatively simple. So um, if we go over here, I'm just parsing the CLI.
So on the client, it will just traverse through the files on the file system, right?
Yes. Yeah.
Yeah, I just one of options would be to use the same approach on server side, like we just store the file tree structure and then run it with pointing it to these files on the file system.
Mm.
Not sure if it's fastest, but yeah, it's minor thing. I mean, it's just possible to do it if preferred.
That would be
Yep.
interesting. So we would do like a git clone and take all the files from the
Yeah,
specific indexing job and then just point it to that, is what you're
yeah,
saying?
yeah. Because then I'm thinking then you could reuse this parallel processing if you would
Hmm.
use streaming file by file. Uh,
Yeah,
then you
might be slow.
cannot. Yeah, exactly.
Okay.
I have a question about interface of this. Maybe we need to take a little bit step back and in order to understand. Well, for me, or maybe I need to read a couple of things. So we have this to code parser and knowledge graph, and What would be the input and output of these libraries? I assume code parser can be a library, a crate, and it will be used as we will include it in knowledge graph and like to get information about the code itself. What
Yes.
would be the binary and what will this binary will do? Like in very simple way, will it accept some arguments as a directory or stuff like that? And what would be the
On the
output of
indexer,
this?
on the
Yeah.
indexer side or the parser side? Which one are you referring to?
So we will probably need to start from knowledge graph because let's say we want to index the repository.
Yeah.
What is the binary we are going to call from the similar
Yeah.
way as we call Zuct, and what will binary do in a simple way?
That makes sense. Okay, I see what you're saying. So the code parser, right, I mean, this will also expose Go bindings, but the embeddings team, I think, will just use the Go bindings for the code parser directly, right?
Okay,
But
yeah,
the knowledge graph project will consume this as a crate, right? So it'll just
right.
import the and then the knowledge graph, we can create the same Go bindings for FFI and build the binary and export it. And then the Zooked indexer can import the Go bindings and all of the code. And actually, that's what I was sharing with Anna Springfield recently for how we can actually publish the Go bindings. It's really interesting. So let me show you Kuzu Go. Um, so what happens is, so Kuzu, their Go bindings, what they do is they compile the actual C++ code directly, and they commit it directly to, the repository itself. Um,
Yeah, I know.
yeah,
I
and
had to recompile this.
Yeah. And so what I was thinking we can do is essentially the same thing where we expose the Go FFI bindings from the knowledge graph itself for anything that the server is going to need. So, I mean, we could use a binary and just use a CLI if we go with the approach that it's not going to be passing data back and forth with the Go process. If you guys prefer that we do like a CLI type of approach where it uses SDN or SD um, we could do that as well. But what I was thinking, at least, is like, or we have options. We can either do, Go bindings talking directly to the Rust code, in which case we probably only need Linux, right? Is my guess. Um, but
So for our needs, well, for releasing this to customers, I think we would need more architectures here and more systems other than, uh, but yeah, uh, I think that for now I would just use what is the easiest way, and
yeah,
we can reiterate on it later. Yeah, if
yeah.
it's easiest to just use separate binary, then let's try it,
Mhm.
and we can change it later.
Okay. Yeah, we can try that
So
too.
so both
Or
of these crates would be just exposing the list of FFI functions, and then Go binary will access them. Did I get it right?
Yeah, that's what I was thinking. But Yam is saying maybe it might make sense to just check out the Go process checks out the files, puts them on disk, and then we just say, hey, indexer, start indexing. Is that what you were saying?
Yeah, I'm not saying it's better. I'm saying that both is possible. Yeah, so it depends on what is better regarding performance or complexity and stuff like this. Yeah.
Yeah, yeah.
If you put it on disk, then the Rust application we'll just accept the, I don't know, web path.
Yeah.
We'll do some work and store into the Kuzu database. It can also accept the path for Kuzu database if we need it. I don't know. I'm just
So
trying to understand. So when we
uh,
start building this, what we need to build.
Yeah.
For me as a like
Yeah. Yeah. Yeah.
as a developer, what to do, and
That's the
this
good point.
making it as a CLI application with just you feed it the path to the disk and do it sounds simpler because you don't need to
Yeah. Do all
all
the
this
binding. Yeah.
FFI stuff
Yeah.
and
Is that possible though? So is it possible in the indexer worker to just essentially what you would have on like a regular computer, like a local client desktop?
yeah, this part I don't know.
You online.
so I don't see why it shouldn't be possible. I mean, having a separate actually, let me think.
Like, could the Go
It
binary spin up a process and just execute?
Yeah, this is of course possible, but I'm thinking about it from distribution point of view.
Oh, okay. Hmm.
B- So we should for sure check with search team, Zook search team, if they have some preference regarding this. But I would say that it's possible. I know that we do something similar with Zook, with Elasticsearch Indexer on Sidekick nodes, where we execute binary, I mean this Elasticsearch indexer, we execute this binary from a worker. Yeah.
Okay.
So in general, this approach is already used in on other places. The question is what is best for our needs.
Mhm.
Now I think we still should go to this CLI path. At least we can test it locally and run, and then and later we can also expose with FFI function. It doesn't really hurt,
Yeah, there's no,
I think,
yeah,
performance.
we
It's
can
just
iterate.
it's just entry
Mhm.
point, and yeah, I think we can start with this at least to test it locally against the local files
Yeah.
and do all this parsing and storing, and then
So
if
this
it's not,
storing,
yeah,
I would expect that the parser still outputs returns the result to either to standard output or to some file, and then the indexer itself will take care of handling this result. I mean, I would prefer not the parser to store directly to the Kuzu
yeah,
database.
I think a parser is just a library. It provides functionality to you say from code
Mhm.
from knowledge graph. You say, "Give me Ruby classes," and code parsers gives you. It's just a library. It doesn't for our needs.
Yeah,
It probably doesn't even need to have a like a binary itself. You can just include it as a library for different purposes. For
Yeah.
the chat with codebase, we might need this if we want to use directly, but. Uh, we
But the indexer, yeah, I mean, we can store it to, we can either write it directly to the Kuzu file, like or we can output, the CSVs, and then the Go indexer can just point it, say, hey, import
yeah,
XYZ. The only potential gotcha there is there might be like the logic of what queries to execute, right? So let me just show you. In the old version, when I did the initial Rust conversion, wait, sorry, this isn't it. Knowledge graph old. Um, I'm actually executing import from whatever. Import, where is it? I think it's like copy from is the um, forgot where I wrote it. Enable bulk import. Yeah, here it is. So you can see like we're defining the tables in the code itself. So if the Go indexer is going to facilitate the loading of the output files into Kuzu, where there might be some duplication there as far as like, what fields and schemas and any special logic might need to be done, but it might not be
I see.
there might not be too much duplication,
I
but
see.
um,
Yeah, we might need to pass some metadata information together with this output, this
mhm.
CSV output files, like pointing to what table to use for importing or stuff like this.
Yeah, that
Yeah,
might be
that's
a
that's a
nice
good
approach.
point. Hmm.
That could be an approach as well. Like when we output the data, we can specify what does the schema look like, right? Um, yeah, so and that was one thing that I wanted to comment on is we're either way, we're still going to need an intermediary key value store to like actually store the data, right? Potentially do any lookups or resolution across files in the future if we want to do any more advanced linking. Um, and then um, we'll need to specify the actual Kuzu schema, right? And all the fields and all that stuff. So, and the one downside about Kuzu is they don't have like a SQL builder, right? Like a SQL query client builder. And there's definitely no ORM. So, I'm thinking when we start this, it would be good to approach it with like because Rust is very highly typed, so we can actually probably build a few schema types and construct the queries and maybe not queries, but all the scheme like the schema and the relationships in a very type safe way. I think that's something we should do when we actually start it. Um, that's just an implementation detail. But yeah, I just wanted to show you guys quickly the rest of this here. Any other questions though?
Do we treat this code base as a POC still, or is it
Um,
production ready? Because
no,
it
not for
depends how we.
no, I think, but I
We
want
can
to,
always refactor this, and but
yeah, I was gonna say I think we should just start and start working together and start pushing code. I think that would be the best approach. Um, but um, I wanted to talk about that too, but let me just show you here. So it's
so,
like this
sorry, just quickly to summarize, because I think you're switching topic, and so since we will have this CLI application, I don't have a lot of Rust knowledge, so it will be slow, but I will start looking into how to build this CLI to receive path and then do something, and at the beginning
yeah,
maybe output, and then
yeah.
yeah, that sounds right.
Yeah, I'll send you some code too. All this code I'm gonna publish and like we'll have it and we can start iterating on it. I wanted to show you guys one other thing I did over the
Sure.
weekend to kind of learn all of this stuff as well. But I didn't want to necessarily work on the topic itself. I was kind of like I just wanted to have fun. So I'll show you guys what I mean in a second. But um, so essentially, what this does is creates similar to Go. It creates like a few channels and spawns some threads. And it uses a pattern of essentially spinning up, like I did with the old DaVinci uh, what I did last year. First we collect all the files. So let me find this. Where is it? So it just collects all the Ruby files. So first it walks the entire thing, collects it, and also any related information. So like file size and whatnot. and we can optimize this. This is like all stuff that we're gonna probably need to refine over time because this is where the money is. Like getting this as fast as possible is going to be very key. And so this gets the list of files, and then what I do is I spin up workers, fixed amount of workers. I just put that as a CLI argument, and it spins up a worker thread for actually chunking out the files. And then there's just a file queue, and each worker picks up a new file whenever it's done processing one file, essentially. Um, so that's how this works here. So you can see worker message result, right? It sends the results back. Um, and yeah, so then here's the worker thread definition. So this is where it actually spawns it. So you can see this is the worker task here, and then actually starts processing it. So it's like not too much investment, right? Uh, and then if we go here and I run it, this is on the monolith. So I'll just put 10 worker threads. Um, and so it's relatively fast, but I think we can make it faster. So these are the number of files it's processing right now. So it's about 5,000 files in. So I was hoping of getting this like, you know, potentially even faster, but this is using the code parser library, right? To extract the definitions and stuff. I'm not actually saving the definitions and references right now, because I decided not to write anything for now, just for POC purposes. But this is roughly the processing speed. It's a little bit heavy on CPU, so you can see CPU loads kind of high. Memory usage is pretty good though. If I type in knowledge graph, um, it'll be roughly equivalent to whatever's stored in memory, right? Um, but yeah, this is kind of the speed that we're looking at. At least me just hacking around with it. And then the AST grep is way faster, so I need to figure out how they got it so fast. But yeah, and then it'll process however many Ruby files there are. I think there are like 40 or 50,000 files in the monolith. So, um, but yeah, um, that's just like demonstrating a little bit of the parsing. I want to get it faster though. I don't think it's fast enough yet. Um, the AST grep, it was able to scan the monolith like I showed you, Jan, in like a few a few seconds, all the JavaScript files at least, which is probably less than the Ruby files. So that might lead to the bias of the result, but
Yeah,
um,
that's cool. I think we can optimize later. I mean, it's fine to get something working and we can iterate on improvements. Yeah, as long as the parsing will take, for example, minutes, that's completely fine for server-side usage. As long as it's not, for example, few hours,
few
because
hours.
then, yeah. So, so yeah,
Uh,
this looks cool. Thank you very
but
much.
what were you
Uh,
saying?
yeah, I will have to go because I have to run an errand. But I can keep the Zoom meeting running if you
Yeah,
want to discuss details. Thank you very
yeah.
much.
But
Have a nice
I
Becomes
day.
a
think
bit of
that's enough for like a first step, and we can sync later
Ah,
next
okay.
okay.
week. And I mean, again, I still have very limited basic Rust knowledge, so it will take me time to start contributing. So, and I think the first
Mhm.
steps are pretty clear enough for now. And yeah, I will try to do
Yeah,
something.
if you, Vital, if you have some capacity to look at it in upcoming days, that would be great because I'm still focusing on
Yeah.
finishing the server-side architecture document, which
Makes
I
sense.
hope
Yeah.
will be close. So yeah,
Yes.
we can reiterate or sync up next week. But
Yeah.
this looks great. Thank you.
Yeah. So, but before you go, I definitely want to like, if you guys are down, I would like to just start, right? If we can, you know,
Yeah, for
code.
this parser side or knowledge graph logic in
Yeah.
Rust, which
Core
calls
logic.
parser. Yeah, I think it makes sense to not doing POC, but just start pushing to the
Yeah.
repository. It's a new project and it's slightly different from POCs we were
Yeah.
doing or we are doing for the monolith side or something like that. So yeah, I agree that just getting the parser uh, as soon as possible would be best.
Yes. Yeah.
Yes.
Um,
Yeah.
We will need
I
this
will start
part
looking into
from
this,
the
but yeah,
beginning.
again, as I mentioned, it will be not that fast. It will be slow. But
Cool.
yeah, I'm excited to
yeah.
work with you guys though. I'm
Yeah, me
really excited.
too. It's very exciting.
I think it's gonna be a lot of fun.
Yeah,
I'm
for
very,
sure.
um, this is probably the most excited I've been at GitLab. So, um,
Cool.
I don't know. I'm
All right.
kind of
Awesome.
Yeah. See you on Friday. I think we have now one different one.
yes. Okay.
Mhm.
All right.
All right. Have a
Cool.
nice evening.
Have a
Bye.
nice
Good day.
day. Bye.